Okay, so section 1.5 covers solving linear equations and inequalities. Really what we're doing is we are trying to find the numbers that we can plug in for x and make the statement true. In order to do that, we just rearrange everything using distributive property, adding and subtracting, and all of that to make it say x equals. So for this first one here, we're going to distribute the 3 to get rid of these parentheses, which is multiplying. And then on this side, we're going to distribute the negative sign to get rid of those parentheses. Now we can combine like terms on both sides of the equation. Now let's bring the 2 to the right. And we want to bring the x to the left. We always do this by the opposite. So since it's positive, we're subtracting, or since it's negative, we're adding. Now to get the x alone, we're going to divide both sides by 7 to undo that multiplication. And we get x equals 2. On this one, it's the same thing. We just want to start by getting rid of the denominators. So we're going to use the least common denominator, which in this case is 6, because 2 goes into 6. So we multiply everything by 6. So if I distribute here, we get this. If I distribute here, we get this. And if I distribute here, we get negative 24. Now let's simplify. 6 divided by 6 is 1, so that's actually going to cancel on the first fraction. 6 divided by 2 is 3, so that's going to leave a 3 on the top. And now we have no more fractions, and we can do what we did on the first one. We're going to distribute to get rid of the parentheses. So we get this. Combine like terms on the left. So we get 7x minus 17. Now we want to bring that 17 over. So since it's subtraction, we're going to add. And then to undo that multiplication, we divide. And we get x is negative 1. So if we plug negative 1 back in, that should work. So like fractions, decimals shouldn't scare you because you can get rid of them. So we figure out the greatest place value. So these go to hundredths, meaning 2 decimal places. So we're going to multiply each thing by 100. So this term would become 6x. And this is all one term because of the multiplication. So if I do that times the 0.09, we're going to just turn that into 9 and leave the parentheses alone. And then same thing over here. It's multiplication, so we only have to do it to the first one. Some people prefer to distribute first so there's no parentheses and they don't mess up. But if you remember that the parentheses are part of that term, like kind of like the x on this first term, then you just multiply it by the number on the outside. Now again, we solve like the first one. So we're going to distribute, and 9 times 15 is 135, minus 9x, and then 7 times 15 is 105. Combine like terms. Subtract 135 from both sides. And then divide by negative 3 to get the x alone. We have x equals 10. So that's how you solve equations. Let's move on. Another way to solve is to graph and find the intersection point. So using our graphing calculator, we can plug one side into L1 exactly as it is. And then we can plug the other side into Y2 exactly as it is. So in order to do that, we're going to take our calculator. We're going to hit Y equals, which is that top left button there. And we're going to type 6x minus 4 parentheses 3 minus 2x. And then on this one, 5. X minus 4 minus 10. Now we were playing with it before, so I use this on the last section. So we're going to hit zoom 6, which zooms us to a standard screen 10 by 10. So go down to standard. And now we have our 2 lines. We don't see where they cross. So we can try zooming out. So to zoom out, you hit zoom 3. And just keep doing that until we see the cross. Zoom 3, zoom 3. And some calculators might zoom faster. But there, now we can see the blue and the red lines crossing. And the calculator, we're going to use it to tell us where. So we're going to hit second, which is the blue button. We're going to hit trace, which is in the top row, close to the graph button. So second trace. And then we're going to choose number 5, intersect. Then your calculator is going to say first curve, second curve, third curve. So you're just going to hit enter to each thing. This one's a little bit different. So if you're using this one, it says left bound. So we're going to move this little spider looking thing to the left of the intersection and then move it to the right of the intersection, and it'll tell us the intersection point of -6, -60. If you have a TI-83, those same questions are going to be first curve, second curve, guess. So you put the spider on the blue line, hit enter, put it on the red line, hit enter. Arrow, use the arrows to move over to the intersection, hit enter, and it'll spit out the coordinates. All right, so inequalities. That's when you have your less than, greater than, less than or equal to, greater than or equal to. You solve them exactly the same way. There's only one step that's different, which I'll show you in this first one. Excuse me. So the first thing we want to do is get rid of the parentheses. So I'm going to distribute the -2. We're going to combine like terms. I want to get the x's on one side, so I'm going to subtract 2x from both sides here. And then I'm going to add the 8 over here. So far, nothing has been different. The next step is still the same. We're going to divide by -3 to get the x alone. This is where there's the one tiny difference. If you multiply or divide by a negative, you flip your sign. So -3 divided by -3 is 1, and 9 divided by -3 is -3. This sign is going to flip. So we have x is greater than or equal to -3. Interval notation, which you'll learn about later, or you may have learned about in another class, is where we write it with intervals. I'm going to teach you this in, I think, the next chapter. So it's just here to see, or if you're familiar with it from other classes. If it doesn't specify, you can leave it or change it. It's up to you. All right, so let's do this one. A division represents multiplication. Nope. A fraction represents division, and to undo division, we're going to multiply. My brain jumped ahead there. So we're going to multiply both sides by -3, which is going to flip this sign because it's a negative. And here's what we're left with. Cancels here, put on the outside of parentheses there, we're good. Distribute to get rid of the parentheses. Bring the x over so it's on one side. Bring the 9 over so the numbers are alone. Divide by -7. So we're going to flip that again, and we get x is less than 1, which in interval notation would be -∞ to 1. Let me just look. -7. Yeah, okay. So we're good there. All right. And this just tells us we have 2 things. So we just solve them both separately. So for this one, we're going to subtract 1 from both sides. Divide by 2. And because the number we're moving, that 2 is positive, we're not doing anything to the sign. So we get x is greater than or equal to negative 2. Now let's do the same thing for this one. Subtract 1 from both sides. Divide by 2. We get x is less than or equal to 1/2. So those are our answers. Greater than negative 2 and less than or equal to 1/2. That is a true statement. If it asks for interval notation, we say we're going from negative 2 to 1/2. Again, I'll give you more details on that. I'm just putting it out there so you get used to seeing it. Here, we have a 3-way inequality. It's no different. If this was covered, you would solve this by subtracting 5 first. If this was covered, you would solve this by subtracting 5 first. So instead, we're just going to subtract all of them by 5. So we're going to kind of have, it's like having 2 equal signs. So we're going to subtract 5 from all 3 parts. And now to get the x alone, we're going to divide all 3 parts by 3, because that's what's multiplied by x. So we get negative 7/3 is less than x is less than 5. That's a perfectly acceptable answer. In interval notation, it would look like this. All right, and here's one more. Kind of combines all the things. I would pause the video and try it, see how you do, and then check it out. So we distribute. And then here we distribute the negative. There's no terms to combine on the left. On the right, we get this. Now I want to bring the x to the left. Negative 11x. I want to bring the 12 to the right. And I want to divide by negative 11. So that's going to switch our sign and leave it as a fraction. You can put it in a decimal if you want, but the fraction makes your life easier. That would be our solution. If you wanted to put it in interval notation, which again, I'll teach you later, it would look like that. So that is 1-5. Let me know if you have any questions.